Good day, everyone. So we're going to quickly run through lab 1 and 2 for this meantime, and so that we can quickly get across through all the lab session and be on the same page. Okay. So for the lab 1 exercises, these are the following questions that we have to run through, 1 to 5. So the first one is asking us to make a vector, okay, a vector called phrase, whereby we have the following letters and letters as an item into the vector called phrase, and the list of items are 1, 2, 3, 4, and 5. Okay, so already we've been able to show you, or we've been able to go through how to install R and R Studio. Okay, so if you have installed R and R Studio, you just need to copy this and take it to the R Studio, right? So here, my R Studio, so the same word there, it's already in my R Studio. So here, for us to run this code, you can click on the run. So running this code means that already these items, okay, these items are already inside phrase. So how do I know? So if you type phrase, so you can also see that already we have this list of items. We have 1, 2, 3, 4, 5. All right. So we have them right. So the next thing to do is you can want to look at the range, or you want to slice the vector. Okay, so here is 1 to 3, so you can actually look from 1 to 3. This means from 1, 2, and 3. All right, I don't know, so I don't know. 1, 2, 3. Right, so the next one is 3 to 5. So this is item 3 and 4 and 5. So if you run this, so it will also give you item 3 to 5. Okay, so let's look at the next question. The next questions is okay, so the first question therefore is saying, all right, so what is the phrase minus 2 and what is phrase minus 5? So what of also if you have phrase minus 1 to 3, all right? So phrase minus 2, so if you have phrase phrase minus 2, what is the answer to phrase minus 2? It means retrieve, okay? It means you actually retrieve, it means retrieve all elements except element 2, okay? You retrieve all elements so retrieve elements, all elements except 2. So that is the meaning of that. So what of phrase phrase minus 5? Phrase minus 5, if you also run it, so it will also display all elements except 5. Okay, so this one will also retrieve or display retrieve all elements, retrieve all elements except 5. Okay, so then the last one there is phrase, the last one there is phrase minus 1 to minus 3. Okay, so this one is to take elements 1, retrieve elements 1 and 3 alone. Okay, except 1 and 3. So this one is going to retrieve element 1 and 3. So if you check it, element 1 and 3. All right, so it's going to take element 1 and 3, not 1 to 3. 1 and 3. It's going to take element 1 and 3. It's going to take it out. Okay, so that is what this question is saying. So next question is saying, okay, so question number 2 is saying, if you want, if we are looking for I don't, I know I don't, okay, I know I don't. So let me copy this. All right, so next one says I know I don't. So here, sorry. So I know I don't. So we want to retrieve this from the same frame. So if you look at this, this is I know, I is in 1, location 1, I know is in 3, don't is in I don't, okay? So how do you retrieve this? So we're looking for, we can look for 3 and minus 3 and minus 1. We can also look at minus 3 and 5, okay? So if you say minus 3 and 5, it will only pick 3. It will remove from the back, so we can have something like this, phrase, new phrase, let's say new phrase equals combination of this, we can pick this, which has already given us, this has already given us I know, okay? I know I don't know. So this has already comma. So we're also looking for phrase minus 3 to minus 5. So this will give us, so if we check, if you run this, all right, so we already have the result stored inside new frame. So let's check new phrase. So if we check new phrase, what do we have? So I know I don't, okay? So that is what is, so the 3 minus 3 and 5 will go from the back, okay, retrieve, except take away 3 and 5. So we have don't, I don't know, I don't, sorry, I don't remaining, okay? So, but you can also find a way of actually doing this. You can also pick I know I don't. So if you pick, okay, because we want to pick from different elements. So this is pretty good, all right? So, okay, so next one, we want to do summation. So here now, so here, next one. So let's say we have summation of 1 to 5. How do we do that? Summation of 1 to 5. Summation of 1 to 5. So how do we do that? So for example, if you say 1 plus 2 plus 3 plus 4 plus 5. So how do you get that one solved? Okay, so very quickly, you can actually use, there is a built-in function in R called sum, all right? So sum is already there. So if you say sum, so you might need to have, say, sum, okay, 1 to 5, all right? So if you say sum 1 to 5, if you run it, it will give you your answer, 15. Or probably you define your here as 1 to 5, 5 should be right, okay, and say sum A. Okay, so same thing. So 15. So you can first of all define your range, or you put the range within the summation. So you can also say I want to find sum of let's say 1 to 100. 1 to 100. So the result will also come out. So you can also say looking for sum So 1 to 1,000 or 10,000, as the case may be, any number you feel like. So, all right, so result will also come out. All right, so this is also the result. Okay, all right. Okay, so we also talk about sequence. The last question there is a sequence. So we also talk about sequence. Okay, so you can also use sequence. Sequence is to give you a series of number. Okay, depending on the term you gave. Okay, so if I say 5, so I'm expecting it to give me from 1 to 5. Sorry, sequence, not sequence, not capital S. Sequence. Okay, so 1 to 5, I'm expecting it to give me 1 to 5. Okay, so if I say sequence 20, so I'm expecting to give me 1 to 20. Okay, so right, so this is how to solve for the lab 1. So we've I think the 5 questions in lab 1. Okay, so it's completed. All right, so let's go to lab 2. Let's check on the lab 2. Okay, these are the exercises in lab 2. So we want to be able to display all this in the lab 2. But first of all, before we run on this, okay, before we run on this, let's okay, let's first of all work on the lab session. Let me see the lab session. Okay, so let's quickly work on this. This one will give us a pre-information to that. So here, let's work on this. So in the last one, so here we have actually created, last time I told you that there's a data set called cardio. All right, so you can actually put your cardio in a data frame, or you put it in a table. Okay, so when you create a working directory, your data set can be in the working directory, so that when you have a working directory, you don't have to specify the absolute parts of that file anymore. It's because you're already in the working directory. So let me just show you in the code. So here, so I've created a working directory here. So I call it user mark, download, Arrow Lab tutorials, CDS 501, then lab dataset. Okay, so this is my working directory. Okay, so inside this working directory, I already have cardio dataset, right? So you can just, if you're using if you're using Windows, if you're using Windows, you need to have something like C, okay, like that, okay, so to follow your path. But this is a Mac, so if you have you are running Windows, so you have to have a C drive, then you can actually walk through that part. Okay, all right, so here now I have this, so my working directory is set, so I can actually get the working directory. So the working directory is just I've specified so inside this working directory, inside this folder, I already have the cardio data set. Okay, I've already downloaded the file within this directory. Okay, so if I run it, so I'm actually using read table to read this file, separated by semicolon. Okay, then header is true because it has header, it has features. Okay, so if I run it, so it's saved inside a data frame called cardio.df. All right, so it's actually saved in cardio.df. So if you want to know whether cardio.df is a data frame or not, just use the word class. So class shows you that cardio variable. Okay, cardio variable is a data frame. All right. So then I want to look at the data set in summary. I want to look at the descriptive summary of the data set. Okay, using descriptive statistics. Okay, so use summary cardio. All right, summary cardio will show me the descriptive statistics of the data that we have stored in cardio. All right. So here now we have the ID, the age, the gender, the height, the weight. Okay, the cholesterol and all the rest that we have there. All right. So the dimension, just like a doctor said the other time, we have when it comes to tablet structured data sets, we have 2 dimensions. Basically, we have the rows and we have the columns. So you can actually check the dimension of your data set. So when you are looking at the rows and the column, you have the numbers of the rows and you have the numbers of the columns. Okay, so you can use dim to check for that. So if I click this, it means this data set, cardio data set, is having 70,000 instances. Okay, it's having 70,000 records, instances, then 13 features. So if you actually count the features, it should be 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so 13 features, all right, which is correct, right? Then you can also know the name of the features by using names. Then you specify the data frame. So here the names will appear only. So these are the names, these are the features that we have in the data set. All right. So these are the features that we have in the data set. Then next one also, like you can also change, you can rename. Okay, we call it rename. You can rename the feature, the column name. You can rename it so that you get a proper understanding of what a particular column is representing if it's not really properly clear. Okay, like if you count it now in terms of the index, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, this is 10, this is 11, this is 12, and this is 13. Okay, so on this 9, if you check 9 is gluc. So it's not really showing, probably it's not really giving the appropriate meaning that it's supposed to be. So you might want to change it to glucose. So you have the names, then you specify the data frame, then you provide the index of the particular feature you want to change. So if you look at it, 9 is representing glucose, and we want to change it to glucose, right? So if you run this, so we think it has changed. So we can go back, press the upper cursor key. So you press the key so to bring back the command that you have run before. So if you click on, if you press enter, you have the glucose. So you can see that this word has been changed to glucose. If you compare here and here, you can see that this has been changed to glucose. You can also decide to look at it. Let's look at another one. Okay, probably 11, alcohol. So we want to change that one to alcohol. 11 to alcohol. Okay, I want to change 11 to alcohol. Alcohol. All right, so here press enter. Then you can also check back whether that has been changed. So you can see that it's already changed. So you can use this command to rename the feature, the name of the feature, if it is not properly clear. Okay, then you can also look at the data set information. Okay, the overview of the data set, how it does look like, so that it will give you a proper understanding about each and every of the column. Okay, because you need to have proper understanding of the column. So if the column are not properly defined, as a data scientist, you have to redefine the column appropriately, because you have to look at the data set whether it's properly defined. If it's not defined, you have to redefine it, because if you don't redefine it, you might not be able to, if you analyze the data, you might not get an appropriate result. Okay, you might get a result, but it might not be the right or meaningful result you're supposed to get. Okay, so let's check the structure of the data set. If you look at the structure of the data set, now you now have that you have ID integer, correct, age integer, gender is integer, height is integer, weight is numeric, and rest and rest. But if you look at it appropriately, in the last class, Dr. May mentioned that gender is not integer. Gender is either female or male, okay? It's that yes or no, 1 or 2, 1 or 0, depending on the on what you actually specified, okay? So here now you're using 2 and 1, and 2 and 1 are not really valued, they're just like categorical, okay? Categorical. So here, when you see something like this, you need to change, you need to redefine the data set by yourself. So how do you do that? How do you redefine? So here we have Cardiff, so you use the word ampersand, dollar sign, sorry. So if you specify the word dollar sign, it can actually show all the rest of the so let me see. So you can see all the rest of the attributes, okay? So you can see the rest of the attributes, but we need gender. So gender as factor. So this as factor is to convert gender from integer to categorical, to nominal categorical. This one is not ordinal categorical, to convert it to nominal categorical. So if you click on it, if you run it, you discover that it has been done. So you have to check back whether there is a difference between the first structure and the second one. So if I check back, okay, if you look at it, can you see? So now it is now factor, 2 levels. That is, it's either one or 2, male or female, okay? 1 or 2 factors. So 2 levels, sorry, 2 levels. So the command as factor has actually redefined, okay, has redefined our gender for us, which is now appropriate if you're actually doing any modeling work, okay? So that is that. The next one now is to look at, apart from you having your data stored in the CSV file, in a formatted structure, in the file, you can also get your data set from online, okay? You can call it from online. You can take it from online repository. So how do you do that? You use the library how recall, okay? So you can use this library. So if you don't have it here, you go here and install, all right? You install from here, just press R recall. So here you install, just press install, because you have to check install dependency too, because your some packages might need to have other dependency for it to actually run very well on your system. So you can check on the checkbox of install dependency, okay? All right, so here I've already installed it, so I click on the arrow coil. So if I click the arrow coil, so it picks it up. Then I want to pick, so you have also to know the specific pathway of the data. You have to be sure of the path, okay, the ULR of the data set, okay? So from the website. So this is the ULR of the data set we want to actually call. So I've taken it. Then I want to connect with the repository online and take the data set. So I connect. So the data set is already here. So I just want to be able to finally read it. It's inside mcon. So I want to read the data set. It's in this directory online. So I want to take it. Finally, it's also a CSV file. So by this, I've taken the file. Okay, so the file is already here now. You can also check the file. You can quickly go and let's say view car. You can view car. So you can see that car is having buying, maintenance, door, person, luggage boot, safety, and rating. Okay, so this is that. You can also look at the struct, that is the structures of the car. So you can also see that car is character, which is a categorical. Okay, so all of them are categorical. All right, so these are the things you can also check. Okay, so you can actually look at this. All right, so moving on. Next one now is also, you can also get a data from a database. Okay, if you have a database, you can connect with the database and import your file or your data. Okay, you can import your data if you have a database already that you have your file inside database. So basically, if you're using MySQL database, so you need R MySQL. There are other databases like R SQLite, Lite, okay, SQL, okay, SQLite. We have R SQLite. We have RSQL. So we have so many of the databases. So depends on the one you are used to. Okay, so you can take your database R Progress, R Oracle. I think we have R Oracle. Okay, so we have R Oracle and all that. Okay, so depending on the database you're using, but here now we are specifying R MySQL. Okay, so if you don't have, you can also do R MySQL. You install it. All right, so after you have installed it, you take it, you call the library. The library is called. So any moment you want to use the package, you have to call the library. You have to call the package using library. All right. So this is the command to connect with the library. So it's already connected, and we want to take the Twitter and the host connection, and we want to put the connection. We want to take the table list tables to retrieve that. So we've already retrieved the information inside the tables, so we can also look at the structure. So this is the structure. It's a character, comment, and tweet, and the users. Okay, so we have the structure of the data table is we have a comment, tweet, and users. So can we view this? Can we also view this table? View tables. Let's see. Is it view tables or view? Okay, view tables. So let's see whether we can view tables. All right. So this is what we have inside the table. Okay. So all right. Table connection. This. Connection. All right. Okay. All right. So table. Next one. All right. So let's go quickly as we so that we can look at the question. So we've connected. So we can print users. You can print users. Users not fine. Sorry, we have not taken any users. We have not read users, so we need to read users, right? So read users, yes. So we can print users. So these are the users inside the database. So these are the names of users and their login and the details. All right. So that is how to use the database. That's how to use the data within the database. All right. The next one is we call tidyverse. Tidyverse is very, very popular in R. In fact, it's taking center stage in R now because tidyverse is it allows you to do a lot of things like you are actually using SQL. Okay, it takes the power of SQL and programming all together so that you can manipulate your data flexibly. All right. So if you don't have the library, you can also click on install and just say tidyverse. So you can install it here. Tidyverse. Okay. So you can install it. So it also have dependency and all that. So here now we have an example where we have library. So where we have the library tidyverse. So I've called tidyverse. So in the tidyverse, I can put data frame. I can create a data frame, and I can convert my data frame to a table because tidyverse make use of a modern data frame called table. The past event of R deals with data frame, okay? But the new modern trend now in R makes use of table as their data frame, all right? So you can create a data frame. So this data frame now, I'm having A to B 1 to 3 as A column, B column, okay, as a letter 1 to 3, which is going to be A, B, C. And I also have column C, which is system date, all right? So you can have something like this. You can create your own data frame from just a sketchy data, right? So here I've created it. So if you look at that data, you can quickly check it first. We can check data first. We can see data, and let's run it. Okay, so you can see that this is data, right? So this is the data frame. So you can see that A column, B column, and C column with 1 to 3, which has been specified as 1 to 3. Then letter 1 to 3 is ABC, and the date also specified according to the last date backward. The last date backward, yeah. Okay, so if you look at this now, here now is the data frame now is converted to table. So for you to convert it to a table format, you call it as table, all right? So if as table, your data frame. So if I run this, so my data table 1 is already a data table. So if I also run this, okay, you will see a difference. Can you see a difference? So this one is showing you like detailed information about each of the data set, all right? Each of the column without you even using struct or showing the structure using STR. STR is already showing you the structure of the data set. So it will tell you that it's a tree. It will tell you the rows, the columns, and all that. You can see it's 3 by 3, meaning 1, 2, 3, 1, 2, 3, 3 columns and 3 rows. All right. So this is how to use a table. So very quickly, let's see other things that are also in the notes. Okay. Connected to this, taking user. Okay, so next one now is to look at, there's another package we want to quickly look at. So the package is nFlight, okay? So if you don't have this package, you can also install it. If you don't have this package, you can also install this package. Copy. Let's go and see. So this package, I think I've installed it. So you copy, you install, right? So you install this package. One or more packages to be uploaded are currently loaded. So it's currently loaded. So I don't need to install it. All right. So I just need to quickly bring the looked at the library. Okay. So bring the library. All right. So the library is on. So this library contains flight information, right? It contains flight information. So let's check it out. So it contains flight information. You can check flights. Let's see whether we have flight information, right? So it has flight information and it's a table, all right? It's a table type of data, okay? So we have 336,776 observations, instances, and it has 19 columns, all right? It has 19 columns or 19 features. So this is the data set. And each of the features, you can see that integer, just the description that is provided, all right? So next thing is we want to be able to, let's say we want to print out of this, we want to display 20, okay, with infinity width. So 20. So here is going to show us we are displaying 20 rows. Okay, 1 to 20. Can you see? 1 to 20. N equals to 20. We are printing flight print. N equals to 20 with all the columns. All right. So with all the columns. So you can see that width infinity, it will show the width completely of all the columns. It will show the width. It will not cut. If you compare with this, you can see that here now it's not showing the complete width. You're not seeing the complete number of the width. 1, 2, 3, 4, 5, and the rest are just shrinked up. But here, the command here is width is infinity. That is, specify all the width. Show all the width of the features of the columns. So you can see year, month. If you count it, you can see that it's completely shown. Okay, but 20, show 20. So if you change this, if you like, you can change it to another thing and say, let's say, sorry, if I like here, I can go back and say, I need something like 30 or 25, all right? So if you say 30 and you run it again, it's going to show you 30, right? So 30 is shown. So if you look at it, 1 to 30, right? 1 to 30. Okay, so that is how 2D verse works. All right, so you also might want to show flights, okay, filter. Let's say I told you that earlier on that it works like SQL. You know, in SQL, you might want to filter your data. Okay, so here now we have flight. I want to filter flight that are equals to 2 months. That is, month equals to 2 and day equals to 1. That is, I need flight that falls within month equals to 2. That is, second month, maybe month is February, and the day is day 1. Okay, filter, and you give it the result. All right. So if you check the dates, if you check the month, you discover that the month is second month. All the flights in the second month, all the flights in the second month and day 1. Second month and day 1. Second month and day 1. So that is the condition. If you check it very well, you will discover that it's showing, it's saying second month filter flights, which is the data frame, which is the data, which is the data table, which is the table. If you check it, it's our table. Yes, it's our table. All right. So what we need is month, which is month is there. Month is the column. We need day. That is maybe the condition of. You can also specify any condition as much as you actually like. Okay. So you can come back and say, I need year. Okay. So let's say we have year. Another condition is let's say year. Year equals to 2013. Okay, or let's say 2012. Do we have 2012 there? If we have, I don't know. So let's say, oh, okay, no 2012. So let's check another thing. Okay, let's say we check for another month. So let's say month equals to 5. Month equals to 5, and day equals to, let's say, day 14. Let's say we have this. Do we have data set there? Okay, yeah. So we can see that this is day month 5 and day 14. Only flights. How many flights? 10. 10 only in this range. 10 only. But if you look here, we also have 10 only. So it depends on also range we also give. So filter will filter for you as much as possible. Okay. All right. So very quickly, let's go on. Month equals to 2. I've talked about this. So you can also use greater than, less than. You can use different operator. Let's say not equals to, equals to. Okay. So let me just quickly show you that. Here now, you can decide to say, okay, let me come back here and say day less than. Show me all the days that are less than 14 days. Okay. So it will show you. So you can see that all the days that are less than 14 days. It will show you all the days that are less than 14 days. Okay? All the days that are less than 14 days. But it can only show 10. So you can also show days that are not equals to 14. Okay? Let's say not equals to. Let's check it out. So here, not equals to. Yeah. Not equals to. Okay, so if you run this, it will also show all the days that are not equals to 14. All right, but if you want 14 inclusive, let's say you want 14 less than, or let's say, okay, let's say greater than or equal to 14. That is from 14 upward, all the flights in month 5, but their days are 14, day 14 upward. Okay, so it will show you from 14 to the rest of the days. Okay. So that is how it was, just like SQL. Okay, it was just like SQL. let's say you want to pick between October and November, in between. You can also use or, and. You can also combine those features as much as possible together, okay? Like this one now. Okay, let me copy this. I will explain this to you. This one. Okay. So here now it's saying ho. Okay? Ho. That is, ho is whether it's month 10 or month 11. All right? Now I can come back and join another. I can, okay, first of all, let me run this and I'll retrieve back and I'll show you something. Okay, so this flight, so if you say flight, flight November, October, so the result is out, right? So the result is out. So you can press and you see the results, okay? So next, let me show you something. Let's say I have flights, okay? And I need this to be true, either this, what's wrong? Okay, so either this, okay, so and, let's check and. What is and? And is ampersand, okay? So and day, let's check our day. We want day, okay? Day, let's say day equals to 14, okay? That means it's either month is 10 or month is 11. But the day must be 14. So whenever the two conditions are true, and means the two must be true. Okay? The two must be true. So, I'm supposed to change this variable. Let me change this variable. So November, day 14. Day 14. Okay? So let me run this. All right. So if you have this flight, let's check it out, day 14. Okay, so there are results. So this is hand joining month condition and day condition together. All right, so pretty good. You can have this. Then you can also specify months in. You can specify months. Okay, you can specify months. So this is saying months. October, November, and December. Okay, so any month in this month, in all these months. So let's say from here, so you can understand very well. So 4 months, the price. So if you check flight, I need to change that variable first. So that my main price. So let's say I have September. Okay. So here, you can just run it, and let's say flight September, November. So do we have results? Yeah. So it's showing out of the 4 months. So you can see result in the 4 months. Okay, in the 4 months, which is pretty also okay. All right. So you can also arrange. Okay. So you can use the word arrange also to arrange in ascending or descending order. You can arrange the year. You can. Okay. So here you can use arrange. You can use arrange. So arrange will arrange the year in ascending order. So arrange index on year, starting with the year, month, and the day. So it arrange it in ascending order. So you can also check the details of that. Then you can also use the word select. Select is just like SQL. It works perfectly like SQL command. You can select the flight year and okay. So first of all, okay, let me run this. this one will show you how to use, instead of ascending order, you can also use the descending order. So it will show flight information in descending order on delay, on arrival delay. Okay, arrival delay. So if we check this, so if you check arrival delay, it must have been arranged in the descending order. Arrival delay. Okay, if you check it here, so I think this is arrival delay on 5. All right. So yeah. So if you check it here now, you can see that this is 1272, 1272, 1109, just like that. Okay. So this arrangement is based on index on arrival delay. Okay, it's based on arrival delay. All right. So you can also use select. You can use select. You can use select to select your flight day, and year. Just check this. So it will show only the year to date. Okay, so from here, because the column is sequential, year to day. Between year and day, we have year, month, and day. All right. So it will show it. So if you like, you can change this for you to understand the concept depth time. So let me change it to depth time. If I'm correct, let's check that. DP. Okay, so let's check it out. So you can see that it's actually selecting. So the range, that is column year to depth time, you can select. Okay, you can also check the selection out. There are a lot of command under that selection. You can do SQL like command, select starting, arrival, renaming, and all sort of. You can also summarize. Okay, you can summarize your data. You can look at the arrival time, whether it's true or not. Okay, so from here, let's check on the exercises. Let me check. Okay, so on the exercises, find all the arrival. Find all the arrival time. So here, find all the arrival time. So if you say find all the arrival time, so let's look at it. Is it arrival time? No. That's the last one. So all the arrival time, arrival delay. Okay, so find all flights that had an arrival delay of 3 or more hours. Okay, so 3 or more hours. The ones that have 3 or more hours, 3 hours, 1 hour is 60 minutes, right? So if you're looking at those that have more than 3 hours more, so it's going to be 180, okay? So more than, that is greater or equals to 180. So if you run this, pretty good. So we can have arrival time. Those that are, you can check it, those that I have arrival delay. So if you look at arrival delay, if you check all these values now, you discover that those are the values that are equal to or more than 180. All right. So the next one is find all flights that were operated by U.S. Airways. So all the U.S. Airways are UA, Delta Airline, Virginia America, and their codes, their carrier code is UA, DA, and VS. So for you to do that, we are looking at, remember, we are looking at, we have done this one before. I'll just need to show you. Let me take it back and show you something here. Okay, remember when we are looking at months, so we want months that are within this specified months, just like a set of months. So we have a set of 4 months. So we are looking at our months, whether there are months, all our months, whether they fall within this range of sets. Okay. specify set. So just like the same thing, we are looking for all American. So all American airlines are UA, DL, and VS. So we are looking at it. We are looking at the carrier. So the carrier, yes. So this is the carrier. You can see the carrier code here. So if you look at the carrier code, you can check the carrier code. So this one will give us all the American. Sorry. Okay. Why is 0? So this is supposed to give us a find all flight filter. P Control C. Carrier. Oh, okay. Problem computing. Cannot find function. Oh, so I've seen that. So we need to check on this. So there's a mistake here. So we need to go back and correct it. So there's a mistake here. You can find it, yeah, here. So this should be resolved now. Okay, so resolved. All right, so this is solved. So you can see that this is the correct answer. So here the other time, the bracket is not closed because here you can see that there's a bracket here. There's a bracket open here. So there's another one here, and there's another one that you should close it. So it should be. So this is the correct way of writing it. All right. So you can see. Then the him is having a T, which is wrong. Okay. So the correct way of writing it is here. You can quickly check that one out. So correct, and you have. So these are all the carriers. So if you look at it now, you can see UA, DL, UA, and all that. So these are all the carriers of American. So the 3 carriers from America: UA, DL, and VS. So you use this command to filter that out. Okay. Okay, so the next one, let's look at this. Copy. So the import the data from the other table. So you have to import data from the other tables. Okay, let's check the other tables. So here, let me here. So if you look at tweets, you can see that we have how many tables do we have? So if you go back, let's check it back. Let's quickly go back. Can I still find it? All right. Okay. So are we there? All right. So we have users. So we have users. We have table. Okay. Yeah. So we have comments. We have tweets. It needs to be tweets, and we have users. So we have three tables there. Okay. So how do we connect with the rest of the tables? So you just use their same logic here. You can see users equals to db read tables, connection, users. So the next one is tweet, read table, connection, tweets. Next one is comment, read table, connection, tweets. So if you read it, so this one is, we have it, so you can check it out. You can check the table out, tweets. So if you check the word tweet, so you can see the table that we have the tweet there. So you can also connect with the second one. Connect with the second one, comment. You can connect with comment, and you can also check what is in comment. Okay, so these are what we have in comment: message, nice, thank you, and all that. Okay, so that is how to connect with other tables in that database. All right, so print. So I've actually done that. I've done this. You can use the word print, or you just quickly type on that. Determine the relation among them. So what is the relation among them? The two data contain, okay. Okay. All right. So what is the relationship between them? So if you look at the relationship between them, so the user ID here, the user ID here is also the user ID, is this user ID here, connect this user ID here. Okay. User ID, probably in this table as a primary key, then here it could also be, it's a primary key to this table. User ID is a primary key to comment table. Why user ID is also a primary key to tweet table. But if depending on the table that is in view, if we are currently on tweet table, the user ID here becomes a foreign key to tweet table. Okay, so you have to understand that concept. And lastly, there, what is the tweet message? Who posts the tweet? Who posts the comment? All right. So you can also check. So if in case you're looking at that, so let's check. What is the message? So if you look at the message, let's look at the relation. Tweet 87. What is the message? Nice. 7 user ID. If you check 7 here, what is the post? Just eat on apple, simply and healthy. So you can make a relationship like that. Okay. Now if you look at it, 49 tweet ID 49, user ID 5. What is the message? Love it. Now if you go back to see what is tweet, what is the tweet? Tweet 5. Open and crush avocado, hard streams, perfect starter. So I love it. I love it. All right. So that is how to connect all those things together. I think we have been able to look at the 2 labs tutorial, and you can go through as much as possible. But I want to actually say that there's a need for you to make a little bit of more research on using Tidyverse. Tidyverse is very vast. It's very flexible. We have a lot of information that you can actually use. It's like you are using SQL inside R. Okay? So thank you very much, and see you in the next class. Thank you.